Welcome back. I'm developer evangelist Kevin Hoyt. Now, in this series, we've been talking about web standards. In this episode, we're going to talk about device orientation. Technically, we'll be talking about device orientation and device motion, but I'm going to loop that together all under device orientation for the purposes of the discussion. Now, the thing to note, and the thing that I think is interesting about device orientation is if you look up the specifications, you'll find these big headers at the top that says, not stable, don't use it. So consider that a caution. It's the only specification in terms of the ones I'm showing in this series thus far that I've ever seen that kind of big splashy notice on. So keep that in mind. It's very, very much a work in progress. You are at this point on the bleeding edge of the specifications and technology. Your mileage may vary based on your device, whether that be a laptop, a tablet, or a smartphone, or something else entirely. Now, when you're dealing with orientation, you're going to get a couple different events. Again, there's orientation and there's motion. Orientation is, for example, what this guy has in it, my laptop. It has an accelerometer in there, mostly for the purposes of protecting the hard drive, right? If I tilt it too fast, it uses the accelerometer to pick that up and then lock down the hard drive so that I don't end up scraping the disk. The orientation events are then something you might find in your laptop. Now, obviously, that's kind of an awkward use case to be kind of moving your laptop for a game or something like that. But it is there, and there are use cases for it. The other one is device motion, and device motion is something you'll find in a smartphone handset, for example, where they have a full-time dedicated accelerometer for the purposes of providing that sensor data into applications. The difference between them is pretty marked, actually. The device orientation will fire off an alpha, beta, and gamma property. Alpha is essentially kind of a relative compass movement. Beta is a vertical tilt, and gamma is a landscape or not tilt. As compared, for example, and good luck trying to keep track of those three. It's a good thing you don't often have to move your desktop and tilt it, because those are kind of hard properties to remember to deal with. And you'll find that it takes some trial and error to see it in action before you truly kind of get the hang of which ones to use and when. But kind of compare that then, though, to the device motion events, which are plain and simple, X, Y, Z. So X is, if we have our device laying flat, X is going to be right-left motion. Y is going to be a top-to-bottom type of motion. And then Z is gravity. Drop that phone, it'll pick up gravity. And it's interesting that the APIs actually let us call out whether or not we're going to get the acceleration of the device with the gravity property or not. And so you can actually get a hold of that gravity, and who knows what kind of interesting games you can come up with on that one. Now, again, I want to call out that not all devices support orientation or motion. This, like I said, right on the top of the specification, it calls out that this is not stable. Oddly enough, it works great on my MacBook Pro. It works in a number of other devices that you might want to try it with. So your mileage may vary. I've had a lot of great luck so far, but do keep that in mind. So let's jump into the code here. See our application. In this case, we're going to build a very simple kind of golf game. We're going to move the golf ball by moving our laptop in this case, as that's what I have available for me. The application is not particularly complex. There is an image element that represents the hole that the golf ball is going to try to get to, and of course the ball itself that's going to be moving across the greens. The greens itself is filled in via CSS and a repeating background tile. So you have the grass, the hole, and the ball. We're going to try to move the laptop, or tilt the laptop to get device orientation changes to where the ball goes into the hole, and we score. And from there, you throw in all kinds of interesting twists and turns with by modifying any of those properties to make the game a little bit more complex, put obstacles in the way and things like that. Looking at the JavaScript here, we're going to call this doLoad method when the application gets going, the page is loaded. I've done some basic resizing to make sure that things lay out the way I want them to. We won't worry about those details today. And then I call a method called play to start the game. So let's go ahead and take a look at play, where most of this action comes into play. Haha, pun intended, I guess. We'll go ahead and take a look at play. So play is going to be responsible for getting the game going. It's going to actually go ahead and look for that ball, and then it's going to go ahead and position it midway down the screen. Right, because if you're working on some tablets at certain resolutions, or my desktop where the browser might be small one day and bigger the next day, you never know where that is, so you want to be able to pinpoint that, then dynamically put the ball in the center, and then I'm going to push it off the edge a little bit, and that's done with a property called start position, which I've just hard-coded to value how far off the other side I want it to be. The hole also gets laid out via the do resize method you saw earlier, that we didn't cover in specific details, but it's very similar to the same thing. It kind of figures out what the vertical distance is, puts it there, and then CSS tells it how far off the right that whole graphic is. From there, we're going to check and say, hey, if window.device orientation event, that is to say essentially, hey, window property that belongs to the browser, do you have a device orientation event property associated with you? If you do, then we're going to go ahead and add an event listener for it. And that's what's going to happen in terms of the laptop here. If you don't, then just keep going. And in this case, the next if statement is, hey, window that belongs to the browser, do you have a device motion event property associated with you? And that is for us to handle the different motion events. If you do, then in this case, you're probably a tablet or a smartphone, something with a dedicated sensor. And in that case, we'll go ahead and listen for device motion. So the two different event listeners here, either device orientation or device motion. And in this case, I actually tried to, I captured both of them and I tried to normalize them, but let's go ahead and take a look at device orientation. So do device orientation down here. So do device orientation, hey, update the user interface, give it the gamma property and the beta property. Like I said, it's going to take a little while for you to work with those properties before they make sense to you in terms of what you're tilting, but essentially we're going to pass those properties on to the update method. Now, up here is do device motion just above device orientation, and we have acceleration including gravity.x and acceleration including gravity.y, and those would essentially be roughly the same mappings to the event gamma and event beta. So we're going to pass both of those kind of normalized values into an update method and have it go ahead and update to the display every time an event is triggered from that sensor. So let's go ahead and check out the update method. Now there's a ton of stuff that actually goes in here. You can see the horizontal tilt and the vertical tilt essentially is the two values I'm getting. I won't cover all the details of the rest of this particular method, but those, again, are those device orientation, device motion, whichever one is relative to that particular screen. We're going to go ahead and normalize that data, pass it as a horizontal and vertical offset, and we're going to, and those values will be from 0 to 1, either positive or negative. And we'll be able to then to use that to multiply any how far off we want it to be. So let's say, hey, every time you report, if you're off 0.10, then multiply that times 100, and we'll say we'll move that many pixels and so on. So we can move the things around the screen by using those offsets. And the other thing I want to do is, in this case, I'll come down here and say, hey, when the distance between the ball and the hole, now that's just a little trig going on there for you, distance between 2 points. If the distance between the ball and the hole is less than 20 pixels, then we consider the ball to have fallen into the hole and a score. So in this case, we no longer want to worry about the device orientation or the device motion. So in this case, we'll go ahead and say remove those event listeners at this point in time, because we don't, once the ball is in the hole, it can't just magically roll back out and keep going. So we'll go ahead and pull off the event listener, so no more orientation or motion events come to us and the ball sits in the hole where it's supposed to be. At some point in this case, I've said that if they can click on the ball to reset the game and do it all over again, so they would click on the ball will be repositioned over to the other side, and then we would go ahead and call play, which is going to add those event listeners just like we saw earlier. In case of seeing this guy in action here, let me go to the golf game. And at this point, the ball is moving all so slightly. So I guess this table is not entirely and perfectly level. Just little pixels here and there. But as I take the laptop and I pick it up and tilt it toward me, the ball goes down. If I take it and tilt it the other way, the ball is going to go the other way. And of course, then I can tilt it towards the hole, go towards the hole, ball. And there we go, it's gonna move on towards the ball. And if the further I tilt it, the faster it's gonna go. It's gonna go by here, we're gonna slow down. And we're gonna just go around the hole, right over there. Yeah, that's a tricky ball right there. Boing, there it goes, and it's back in the hole. And so there we go. We have listened to device orientation events in this case, the tilt of the device to move that. Now, word to the wise here. You remember the reason I can do that with this laptop is because there's a sensor in there that's listening for the hard drive, and I just happen to be able to tap into it via the APIs provided by web standards. But you probably don't want to be testing to make sure that sensor works to protect your hard drive and start shaking your machine too much, and you don't want to damage your hard drive. So a little word of caution there. You might want to, for any kind of physical harsh testing, you might want to move that to a device that has a dedicated sensor, one that has the disk space fairly well protected, for example, a solid state drive or something along those lines where you don't have any moving parts to scratch. So there's an example of using device orientation and or device motion depending on the device and depending on the screen. Be able to play a little golf game there to move a ball down the screen, and you might choose to introduce any kind of different number of permutations on the complexities there, introduce your own kind of sense of gravity if they start moving the device up or down or what have you. I'll leave that to your imagination. There's more to come in this series. Until then, I'll be waiting.